I have given the assignment. Guys, how many of you got the assignment? I am not talking about the completing of assignment. I am just asking how many of you get the assignment. Nawal and Nafis.
The assignments on the app, or
Mm-hmm.
is it like in the app?
Yeah. There is a portal. Nawal, what about you?
No, sir, I didn't get it.
Okay. I am repeating this assignment again. And now get it.
No, sir, I didn't get it too.
There is a portal, na? You don't know about you don't know anything about the portal.
No, it's
PORTEL
not
portal.
there on the portal.
It's not there, sir. It says your subscription has ended, has expired for me. I
Same
don't know
for
what.
me.
Okay. Okay. So we are discussing the series and parallel combination. Now today we will discuss some different types of combinations. I will start the class. Okay. Now I am starting. So our topic is questions on calculating the equivalent resistance. Equivalent resistance. Calculating the equivalent resistance. Today's lecture is very important. So here type 1 here in the type 1 questions you will decide the series and parallel combination with the help of geometry of the network. Series and parallel combination decided by geometry. Earlier we have discussed the series and parallel combination like this. If the resistances are connected like this, then they are considered in the series combination. This type of combination is series combination, and current is same throughout the resistances. And there is one more type of combination, parallel combination, and parallel combination was like this. When the resistances are connected like this, the potential difference across each resistance is same. This was the parallel and this was the series earlier we have discussed. But today we will discuss some different types of networks. Suppose if you have Here is one resistance of R. 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 So we have to find calculate equivalent resistance between number one, suppose this is A, this is B, C and D. This is C and this is D. Between A and C, between A and C, and secondly between A and D. So this is a different type of question. This is a different type of question. You just follow the steps that I am telling and you can solve this question very easily. Now, if you want to find the resistance in this network between A and C, so what you should do, connect the imaginary battery or cell between A and C. Connect cell between A and C. Why I am connecting it between A and C? Because we have to find the resistance between A and C. So I am just connecting a battery between A and C. You have to follow the steps that I am telling. You can easily solve the question. Very, very easily. So you can connect the battery between A and C like this. This is AND A, this is AND B. Now connect a battery with a wire. This is a wire, and just connect this. This is the imaginary battery for understanding whether the connection is parallel or series. We can decide here this combination. Here we cannot decide which type of combination is this. So now this is a cell. You have connected an imaginary cell. Now move from A to B and from B to C. Now this is a single wire. This is a single wire now this time. Here is one connection. Here is one correct connection. Branching is here. From A there are 3 and 4 branching. From C there are 4 branching. But from A to B to C, here is single wire. And in single wire here the current will remain same. Means this combination is the series combination between A and B, A, B, C. This means this resistance and this resistance is connected in series because this is a single wire. There is no branching here. And this resistance and this resistance also in this series. See, between A, D and C, there are no branches. So this R and this R is in the series combination. So I am just modifying this circuit. If this resistance and this resistance are connected in series, then the equivalent resistance will be between this and this. I can add this resistance. This will become 2R. So I can write this as Now we have a single resistance of 2R here. Here is a resistance we have of R. Now when you calculate this resistance and this resistance as they are in series, so you can write this as R plus R2R in series. So you can write this as this resistance as like this. This will become 2R, or you can just made it like this. This is the 2R now, and again this is also 2R. This is also 2R, and here a battery we have connected, or a cell is connected, just to identify. Okay. So now you can see that this combination, this whole combination from here to here is in parallel. Now connect this wire here like this, and here is 2R, this is 2R because this is in series. So now see here, this resistance and this resistance and this resistance are connected end to end. Here the potential difference across this resistance is this, means suppose you have connected a cell of potential difference V. So here is potential difference V, here is potential difference V, across 2R the potential difference V, means this combine all three resistances 2R, R and 2R are connected in parallel combination. So you can write 2R, R and 2R, they all are connected in parallel. So how we will calculate the parallel equivalent resistance? In parallel, 1 upon 2R plus 1 upon R plus 1
Plus
upon
1 upon 2R.
2R, means 1 by R1 if I am taking this as R1, if I am taking this as R2, if I am taking this as R3, then equivalent resistance in parallel combination is like this, and you can solve this. Take the LCM, 2R here 1, here 2, here 1, you will get 4 divided by 2R. So if you want to find the equivalent resistance, then you will write 2R divided by 4, and the answer is R by 2. So this is one of the method. So you have to identify what happened. We have to find the resistance, equivalent resistance between A and C. Now connect a wire here. Now this wire is a single wire, and on a single wire I have told you the current is same, and same current is in the series combination. So this resistance and this resistance is in series combination. This and this also in series combination, and the equivalent of this and this resistance is in the parallel combination. So the equivalent resistance of this circuit is R by 2. Or you can say this connection. All resistances here are connected end to end. Na. This connection is this resistance is connected to this, and this resistance is connected to this, and means this, and this resistance is connected to this end. You have to just identify this is the parallel combination. So we have find the equivalent resistance in this way. So now you can just copy this. You have to just solve the circuit with step by step. Are you writing?
Sir, can you scroll?
Yes, sir. Can you scroll?
This one, na? Okay. Write it. You can ask me to scroll if you want.
Sir, can you scroll?
After this, we will find the equivalent resistance between the point A and D. Between the point A and D.
Yes, sir. Finish.
Nawal, completed?
One second.
Okay.
Done, sir.
Okay, yes, I. So now we have completed this. Now we will solve this A and D, between A and D. So in these types of questions, there will be a time when there is no need to connect the imaginary battery and all that, when you will do the practice. But this is just a starting, so you are doing this. We have to find the equivalent resistance R equivalent between point A and D. Point A and D. So what we will do, we will just connect an imaginary battery here like this. Now we will focus only on these points. So now see here, this is a single wire. This becomes the single wire now. This is a single wire now. Hello, Matthew. Matthew.
Good morning, sir. Good evening, sir.
Okay, no problem. So see here, Matthew, I am just solving this question.
Okay, sir.
Second part of this question. We have solved the first part. Let's see what is the second part. This is the network. See the network first. And we have to find the equivalent resistance between this point A and point D. So in this type of question, what we are doing, we are just uh, identifying the resistances with the help of geometry. Now there is a procedure to solve these kinds of questions. So I am just connecting a imaginary battery to identify the whether the resistances are connected in parallel or in series. So I have just connected a battery. Now you will focus on these points, point A and D, point A and D. Now there are no other points. You can neglect this point B and C. Okay, you can neglect other point. This point is just an illusion, means this is a single wire. So this resistance and this resistance is in the series combination, so I am just modifying this. So always remember, to solve the circuit, to solve the network of resistances, you have to take the solution, you have to solve the question step by step. Okay, you know that these two resistances are connected in series, so first solve this. And we don't know what about this and this, so first just modify the circuit, means make this like this. This and this is in series, so I can write this as 2R, because in series we can add the resistances. R and R become 2R this time, and this R, this is R, and here is a point where the battery is connected or cell is connected. And this is R again, and this is R again. Now see, now we have just calculated this between these two. Now we have to identify this combination. So see here, this 2R and this R, this 2R and this R are connected end to end, are connected end to end. So this R and 2R will be in the parallel combination. Okay, see here now. One thing more here. Guys, are you getting what I am telling?
Yes, sir.
Yes, sir.
Actually, you have to identify this resistance, na, this 2R and R now is in parallel combination. Okay, why? Because see here, this 2R and this R, this 2R and this R are connected end to end, so you can modify this circuit once again. So you can calculate the equivalent of this 2R and R. You can calculate the equivalent of this 2R and R. So how you will calculate? I have told you, 2R into R divided by 2R plus R. So this will become 2R square. This is 3R. And this R and this R cancel. This will become 2 by 3R. 2 by 3R this will become. So instead of this 2R and R, I can write 2 by 3R single resistance. I can just modify this circuit. So I can so instead of this, we can just take one resistance. We can just take one resistance, that is of 2 by 3R. One resistance of 2 by 3R. 2 by 3R, and this resistance is of R. Now we have modified the circuit. Now see here, this is point A and this is point D. This is point A and this is point D. This combination, this is a single wire now. This is a single wire now. So this 2R and this R will be in series combination. Series combination. Okay. So you can write the equivalent of this. Equivalent of this. So you can write the equivalent of this in series combination. You can add the resistances very simply like this. Okay, you can take 3 as LCM. Then you can write 2R plus 3R. This will become 5R divided by 3. So see here. So now modify this circuit once again. Modify this circuit once again. So instead of this hole, you will connect a equivalent resistance of 5 by 3R. 5 by 3R. Just connect this resistance of 5 by 3R. Now you can see this combination, this R and this 5 by 3R are in parallel now. This R end to end connection. This R is connected and one end is connected like this. Means this 5 by 3R and R are connected to end. Means the potential difference across this R and across this 5 by 3R is same. So you can write R and 5 by 3R in parallel. So finally the net resistance or the equivalent resistance of the circuit is the equivalent of these two resistances. Okay guys, so can you
Yes.
find the please find the equivalent resistance of this R and 5 by 3R if they are connected in parallel, and tell me the answer. I have told you if two resistances are connected in parallel combination, for two especially I have told you they are connected in parallel, then you can calculate the equivalent resistance R1 into R2 divided by R1 plus R2 if they are connected in parallel. I have told you now. So you can use that, this formula R1 R2 divided by R1 plus R2.
Yeah, sir.
Yeah, this will be easy for you for solving. So I am just using this formula. You can suppose any one R1. I am supposing this as R1, so I am writing this R means product of both the resistances 5 by 3R and divided by addition of the two resistances 2. So R plus 5 by 3R. So this will become 5 by 3R square. In the denominator, You can take the LCM of this. LCM will become 3. Then you can write here, this will become 3R plus 5R means 8R. Now you can solve this. 5 by 3R square. In the multiplication, you will write this 3 divided by 8R. This R square is cancelled with this and 3 is cancelled with 3. So you will get the equivalent resistance of the circuit as 5 by 8R. The answer is this. The final answer is 5 by 8R. Means the resistance between the point A and D is 5 by 8R. So in this way you can solve. This was the second part of the question. Step by step we have to solve. Now you can note it down. Second part. I have applied here R equivalent for the parallel combination. R1 R2 divided by R1 plus R2 means the product of the resistance you will take on the numerator and the sum of the resistances you will take in the denominator. Matthew, got it?
Yes, sir.
Means in this is the way to identify, means this is the easiest way to identify whether whether resistances are connected in series and parallel combination. Actually this is a mixed combination, so it is difficult to find whether the resistances are connected in series. So just you can connect the cell in between the points, in between those points that you have to find the resistance between those points. Suppose if someone is saying find the equivalent resistance between point A and B, then you will connect the imaginary battery, imaginary cell between point A and B and solve the question accordingly. Okay, and there are no significance of other points.
Sir, can you scroll?
What is it fine now?
Yes, sir.
So in this way you have to solve.
So can you scroll?
Problem. Actually, wait a minute. Shit. Just wait. Hello. Hello.
Yes, sir.
Actually, there is some problem in my laptop. So, guys, wait for just 5 or 6 minutes. Okay, I'm just coming.
Okay, sir. No problem.
All of you, just wait
Okay, sir.
and revise your note. I'm just coming in 5 minutes. I'm just restarting my system. Okay, fine.
Yes, sir. Okay.
Till then, revise your notes. Okay. अरे यार, ये क्या हो रहा है? Are you getting my voice?
Yes, sir.
Yes, sir.
Okay, actually there was some problem, so that's why. Just this is one of the kind of question, the mixed combination. Here, the main thing is to identify. Means the combination. You have to identify the combination. Okay. So you have written this thing. All of you have written
Yes,
this.
sir.
Okay, very good. Now this one.
Yes, sir.
All of you written this one also.
No, sir. I have to write this.
Okay, okay. Please write. And write as I have written. Otherwise, you will get confused in this where 5 ohm resistance is connected, where 3 ohm is connected. You will not get. You have to solve this type of question step by step and connect a imaginary cell. Connect a imaginary cell. And after this, we will solve a question without connecting an imaginary cell. Okay. We will solve the question directly. We will solve the question directly. Should I scroll down?
Yes, sir.
Yes, sir.
Okay. Okay, this is completed now.
Yes, sir. Finish.
Now we will solve a very good question. Just have a patience. Now see. You can see this question. Here is a circular wire is there. Circular wire is there and resistances are connected like this. You can see. Here our resistance of 2 ohm is connected and our resistance of like this 10 ohm and 10 ohm are connected like this. This is the wire. This is a circular wire. This is again a wire. And here are 10 ohm resistance. Here are 10 ohm resistance. And they are saying here a 5 ohm resistance is connected. Now we have to find there are 2 points given. 2 points are given and we have to find the equivalent resistance in between these 2 points. Point A and B are given and we have to calculate the equivalent resistance. Find the equivalent resistance between points A and B. Now I will not connect the cell. That I will solve this question directly. So see this. Now you should look at this network, and this 5 ohm is connected here with this wire, and this 10 ohm is connected with, and we cannot identify, we are not getting which type of connection is this. And but we know we have to find the resistance between this point A and point B. Now see this. You have to identify. There is two resistances here that are connected in series. Now see here, from here to here, this is a single wire. Single wire. What is the meaning of the single wire? Means if this is wire is like this, if this wire is like this, and suppose here is one resistance connected and here is one resistance connected, I can, if I am bending this wire, if I am bending this wire like this, means the wire will remain same. The connection of resistance is series again, na. So same is the case here. You can see this wire is same. Thus, this is the bending to just to get to confuse you. Okay, just to confuse the student, they have made the structure like this. Okay, this is this 10 ohm, this 10 ohm and this 10 ohm are connected in series. So I am supposing this as resistance 1, this as resistance 10, this 10 ohm as resistance 2, this 2 ohm and resistance 3, and this 5 ohm and as resistance 4. So you can see this 10 ohm and 10 ohm is 1 and 2 are connected in series, because this is just a bending of wire. Two resistances are connected, and you have I am telling it again, so don't confuse. Suppose this is the portion of the wire and one resistance is connected here and one resistance connected here. Now this is like this, and I have simply just bent it like this. I have just bent it like this. Means if you are bending the wire, means there are no you are not producing the branches. That is why this 10 ohm and 10 ohm are in series. So you can write 1 and 2. 1 and 2 means 10 ohm and 10 ohm connected in series. So you can find the equivalent resistance of 1 and 2. R1 plus R2, that is 10 plus 10, 20 ohm. Means now instead of this, we have a resistance of 20 ohm. Now we will modify this. Just find the combination and modify the circuit and again solve it. This is the way. And when you will do it many times, you will get into it. You will do that very fast. You can do that very fastly. Okay, no problem. So, are you getting me, all of you?
Yes, sir.
Yes, sir.
Okay. So now what I have done, see here, we have earlier resistance of two resistances connected in series. Now I will connect, this is a same wire, this is a single wire. So I will connect between these 2 points a single resistance of 20 ohm. This is a wire, I can just bend the wire like this and I can do. Okay, I can bend the wire. I can, earlier this wire is like this. Now I have stretched the wire and like this, and here a 20 ohm resistance is connected, and this is a 20 ohm resistance, and this resistance is R23, R12, sorry, R12. We have find R12 as 20 ohm. Now you can see. Now you can see again. Now see this point and this point. This 2 ohm and 20 ohm are connected end to end. 2 ohm and 20 ohm are connected end to end. End to end connection means the parallel combination. So you can write R3. This 3 means R3. Okay. This 3 means R3 and R12 and R12. They are connected in parallel because they are connected end to end. This one end is connected here, one end of both the resistance connected here. So 2 ohm and 20 ohm are in parallel combination. And parallel combination, if you want to find resultant of this R123, then you will write R3 multiplied by R12 divided by R3 plus R12. What is R3? R3 is 2. R3 is 2. R12 is 20. This is R3 is 2 plus this is 20. This will become 40 divided by 22. You can further solve it. R123. You can write this as 20 divided by 11. So now you find the equivalent of these two. Now modify this circuit again. You can also do the question in the one step also, but I am just telling for you. So now you can remove this resistance from here and connect a resistance either on the circular wire, or you can change the shape of the wire. This time this equivalent resistance will become, this will become R123 and this R123 will become 20 by 11. This resistance will become 20 by 11 ohm. This is R123. 123. This resistance. Now, Matthew, tell me, this resistance 4 and this R123, which combination is this?
Series.
Very good. Very good. Series combination, because you can see you have to find the resistance between the point A and B, and now see the wire is same. If the wire is same, I have told you, the current is same, means the series combination. Now you can find the resistance, equivalent resistance between A and B, and this will become R123 plus series combination with add directly resistances, so R4. So this will become 20 by 11 plus 5, and if you will take the LCM, you will get this 11, and cross multiplication, this 20, this is 55. So equivalent resistance between A and B will become 75 divided by 11 ohm. So in this way you can solve the network. You have to just solve the question step by step. First you will identify whether the two resistances or three resistances are connected in series or in parallel. Then after calculating the equivalent resistance, modify your circuit and again solve it. And with the practice you can do this very fastly. Now you can note it down. This is a good question, I will say. This is the wire. This white color thing, na, circular thing. This is a wire. We can just fold the wire like this and stretch the wire. There is no effect on the combination, on the resistance. This combination I can represent like this also. Just for your interest, I am telling. This resistance I can. This is 2 ohm and this is 5 ohm. 5 ohm. This is 2 ohm and this is this kind of combination. Here a 10 ohm is connected and here a 10 ohm is connected. This kind of combination is this. So not this. Actually, you have to take this here. You will connect this here. See, both combinations are same. See, here is 10 ohm. This combination and this combination is same. What I have done, I have just folded the wire. This is a game of the wire. Just means you can fold the wire like this and like this. So this is the same combination. And this is point A and this is point B. So note it down, all of you. If you will calculate the equivalent resistance of this will be same. Means both these circuits are same, but the configuration means wiring is different.
Sir, can you scroll down?
All of you, should I scroll down?
Yes, sir.
Yes, sir.
Okay, fine. Now after this, there is very interesting network, very interesting. That will be a parallel network, but that network is just folded in a way that not that network will not look like a parallel network, but that will be a parallel. We will see that. Should I scroll down?
Yeah, sir.
Okay. When completed, you can tell me.
Done, sir.
All of you completed?
Yes, sir.
Okay,
Yes, sir.
very good. Now see a very interesting circuit. Very interesting. You can say this is just a second type question. Type second question. and we call it potential divider method. Potential, and we have already done this in the parallel combination. I have already told you, but the name is different. Potential divider method. So I have already told you, if the resistances are connected and the potential difference across each resistance is same, the combination is parallel. The combination is parallel. That I will use here. So suppose you have a circuit like this. This is the wire. This line is the wire. Resistance. There is one resistance here. One resistance is here, and one resistance is here. Okay, and this is another end of the conductor. Actually, what is happening? You can feel, you can see this. Imagine this in the practical life. Means suppose this is a wire. This is a wire. Okay, and here one resistance connected, here one resistance connected, and here one resistance connected. Now what I am doing, I am just connecting this with some wire. Here I am connecting this wire like this, and I am just connecting one wire like this. These all are the wires. You have seen the wiring in your homes and in your laptop. There are wires. These are the wires, and the resistance. If this resistance is R, if this resistance is R, if this resistance is R, and we have to find the equivalent resistance between point A and B. Now this circuit is, we cannot identify directly what kind of combination is this, but I know this is the parallel combination. We will see how this will be the parallel combination. So we will use very basic thing. I have told you, at this point take the potential as A. At this point also the potential is A. If you are going downward, here also the potential is A, because in the path, if there is no resistances in the path, if there are no resistance, then the potential is same. Here also the potential is VA. Here also the potential is VA, and here also the potential is VA. Here. Now this is point B. Here is potential B. In the path, when you are moving on the wire, if no resistance, then here also the potential is B. 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 Here also the potential is VB. Here also the potential is VB. See the beauty. If you are just taking this R, now I am just removing all. I am just copying this figure. This is the figure. No, I am just removing all this. I am just removing this. This VA, I am not this. Okay, this is VA. I am just removing this. I am just removing this. This. There is a requirement of this. I am just removing this. We can remove now. I am just removing this and removing this, and this. And there are. This is the single wire. This is again the single wire, and this is the single wire. 3 wires are there. Now tell me the potential difference between point A and B. Oh, sorry. Potential difference if this is a resistance 1, if this is a resistance 2, if this is a resistance 3. Across R1, the potential difference V1 will be, what is the potential difference? VA minus VB. But please remember, the potential difference I am talking about, potential difference means this can be VB minus BA also. Okay, potential difference, I have told you, if two resistances are connected in parallel, then the potential difference of potential will be same. The potential difference can be the difference of VA minus VB or VB minus BA. So across R2 you will calculate across R2 VB minus BA, VA minus VB and VB minus BA will be same. VB minus VA across R3 calculate, again you will get VA minus VB, V3 VA minus. I am supposing I am having two numbers 10 and 5. What is the difference between these two numbers? Difference between these two numbers is 5 now. And this 5 you can write either 10 minus 5, you will get 5. If you will write 5 minus 10, you will get minus 5. But I am just talking about the difference. So if you like this, you can apply this thing, you can apply this thing here. So you can say the potential difference across each resistance here is same. So means all the three resistances are connected in parallel combination. So you can say potential difference across R1 means this, R2 means this, and R3 means this, 3 means R3 is same, means R1, R2 and R3 are connected in parallel. So for the parallel combination, if you want to find the equivalent resistance between A and B, then equivalent resistance between A and B, then you can find it 1 upon R1 means all are connected in parallel, 1 upon R2 plus 1 upon R3. So 1 upon RAV, if you want to find, then you can write, but this is 1 upon R plus 1 upon R plus 1 upon R. So the LCM is R, here is 1 plus 1 plus 1, you will get 3 by R. Now the resistance between A and B, equivalent resistance will be R by 3. So see, this was the parallel combination. This was the parallel combination. Means this combination was like this. This combination was like this. But there is a difference of observing it by the observer. This is the parallel combination. Both the circuits are same. R1, R2, R3. Both are equal, means all are equal. So this was the original circuit. Not the original, but the okay. Got it, all of you?
Yes, sir.
Potential divider method means you have to just calculate the potential difference between across the resistor, between the points between the resistor. And I have told you, if the potential difference across the resistance connected same, then that means there is a parallel combination. So note it down. You can note it down. Now there is one more thing, weight stone bridge, that we will discuss maybe in the next class. So you have to identify which type of combination is this. There are different methods. If you know the basic concept of if there is no resistance in the path, then the potential is same of the point. In a single wire, if the wire is same, then the current is same. Then easily you can find the combination easily. Should I scroll down, guys?
Yes, sir.
Matthew and Nawal?
Yeah, sir. You can scroll.
But you can tell me now if you have written. Why we will waste our time?
Yes, sir. Finish.
Okay, good. And there is very small topic, short circuit. When we will short circuit the resistance, means the existence of resistance will be extinguished. You will see there was a resistance, and resistance will be there, but there will be no resistance. You will see this after this. Have completed all of you?
Just a second, sir. Not yet.
Okay, fine.
Done, sir.
Okay, Nawal.
Yes, sir.
Okay, ठीक है. Now we have some third type of things, third question, like this is very easy. Short circuit. Short circuit. So what is the meaning of short circuit? Suppose you have a resistance like this. Okay. This is a wire. This is a wire, and on this wire a resistance is connected. So now what you have done? You have just connected another wire here. But don't confuse with this. This is not the case of short circuit. I will explain you later. But now focus on this only. Okay. And suppose the current is flowing like this. So here is a path in which there is a resistance, means there is a hindrance. Here is a path. Suppose now I am saying here is a resistance. Okay. The existence of resistance without current is nothing. If there is no current in the resistance, then there is no use of resistance in the circuit. So you will see this. Suppose if you are a current, this is you, and you are a current. You have two paths to reach here at point B. You have started from point A and at point B. And one more thing I want to tell you. If you are going from here to here, or if you are going from here to here to here, the time will same. time taken will be same. If you are moving from this point to this point, either by this path or by this path, the time taken will be same. So if you are moving in this path, there is some hindrance, means there can be some constructions and there can be some noises, and there are some people, there are some crowds you can say, and there is a very beautiful path here. There is no single path, there is a single path, there is no one on that path, and the road is, there is no vehicle on that road, and here on this path you can imagine there are the vehicles. So which path you will choose? This path, I am supposing this path as 1, this path as 2. Which path will you choose? If you are a normal person, I am not talking about the abnormal person. If you are a normal person, some can choose this path also, but I am talking about the normal. So which path will you choose, Matthew?
First one.
First one. Very good. So what will happen? All the current will go along this path. Finish. And this resistance will die. This resistance will die. So if this kind of things is given to you, so just there is no resistance here. Means if this is the thing, this resistance is short circuited. Okay, so you can just represent this as a connecting wire, single connecting wire. Single connecting wire. And why this is happening? Why this is happening? Because now there is no need of resistance. I have told you resistance, the existence of resistance is due to current. But the current changes the path. Now there is no need of resistance in the circuit. You can remove the resistance and throw the resistance out. Okay. One more thing. Suppose if two resistances are connected like this. And you have connected the wire like this, what will happen? You can represent this as a single wire. This time these both the resistance will be short circuited, means all the current will be go in this direction. So you can represent this as a single wire. But there is one more thing here. One more thing here to identify. The examiner can confuse you. In the question paper, the examiner can confuse you by giving you this type of thing. He or she will connect a wire, and another wire is he will connect from here. This is another wire. Now these two resistance will not be short circuited. Okay, because what will happen? Because see here, current, you can say the current will go in this path, along this path, along this path, along this path. You will say there is no current in the resistor, so this will be short circuit. But here also is wire. Due to this wire, the current can enter into the resistance. So this is not the case of short circuit. Understood? Understood now?
Yeah, yes, sir.
Yes, sir.
Very good. So actually, in solving the connections, means resistance in series and parallel, there are confusions. You have to just remove those confusions. So I will take your 10 more minutes. So suppose if three resistances are connected like this, means four resistances are connected like this, and each has the resistance R. And this resistance is connected via, these two resistance are connected by a wire, and here this resistance are connected via wire. but this resistance are connected like this. Now guys, you have to find the resistance between A and B. All of you please solve it by yourself. Tell me the answer. Very easy question. Find the resistance AB between A and B. All of you solve this question by yourself. Identify the circuit. You can check your notes also. And tell me the answer. All the things we have done earlier, but you have to just apply this time. Guys, are you solving this question? Trying to solve?
Yeah, yeah.
Yes,
Okay,
sir.
please. All of you at least try. Circuit means there is an illusion in the circuit. Circuit means illusion. You have to just remove that illusion. If you have removed the illusion, then you can solve very easily in one step also. I want to tell you that the wire is connected from here to here. This is a wire. Here a wire is connected from here to here. Here a wire is connected from here to here. So okay, now leave that. I am solving. All of you leave that. I am solving. So see this resistance. All the current will go along this path. So this resistance will be short circuited. So this resistance will be short circuited. Means there is no existence of this resistance in the circuit. We will not show this resistance. So I am removing this first, this resistance. Step by step I will do this. So we can remove wire also. So there is no resistance here because the resistance is converted into in the form of, means this is the case of this now. This is the case. This was the case earlier. So this was the case. I have just made this single wire, represent that single wire. Now we have already solved this question. Oh, sorry. We have already solved this question.
Yeah,
Matthew?
sir. Yeah, yeah. The potential
This,
divider method.
yeah. We have done this. Na? These are the three resistances connected in parallel combination. These are the three resistances connected in parallel combination. See here. Earlier also we have done this, but you have to identify the things. One wire is connected like this. So all three resistances are connected in the parallel combination. Remove first that this resistance. Why I have removed this? Because this is not a resistance, just looking like a resistance in the circuit. Because this resistance is short circuited. I have just represented this with why single wire you can. So all resistances, all three resistances connected in parallel combination. Can you find the equivalent resistance between A and B? What is the answer?
1 by R1 plus 1 by R2 plus 1 by R3.
Yeah.
Which is all same.
So R1 is R. So you can take the LCM. You will get here. Sorry, here you will get R. Here you will get 3. So answer between the resistance between A and B will be the R by 3. Simple. Okay, note it down. So these kinds of questions you can get in your examinations.
Done, sir.
Done. Okay, fine.
Sir, can you scroll up?
Scroll up. Okay,
Yes.
this one, na? But this
Yes.
point is very, very important. These points are
Yes.
very, very important too. Because you know how to short circuit the resistance. The complexity of the circuit will reduce. And you can solve the questions very, very easily. In the next class, I will start Wheatstone bridge. That is another thing for solving the circuits. And please don't miss the class, all of you.
Yes, sir, finish.
Okay, Nawal, have you finished? I think Nawal is not in the class. So Matthew, have you finished this?
Yeah, sir. Finished. I told
Okay,
already.
so so all of you